We wrote vertex form equations when we were given a parabola. Now, this time what we're going to do is we're going to take an equation that's in vertex form, and we're actually going to create the parabola to go with it. So when we do that, we need to remember that we have three different parts to this vertex form equation. We have an a value, we have an h value, and we have a k value. And so the first thing we want to do is identify the a, the h, and the k. So my a is 2, my h is going to be 3, and my k is going to be 1. Now, a big common mistake here is a lot of kids think that this h value is actually a -3, but remember, our formula for vertex form, this is a subtraction sign. So what this problem actually says is x minus +3. Okay, so my h value is this +3 there. So the h value looks like it's the opposite of what it is in your problem, so don't let that confuse you. Okay, so once we have our a and our h and our k values, we're going to use them to find our vertex. And our vertex, remember, is made up of our h, which is the 3, that's our x value, and then our k value is our y value. So this vertex is going to be at 3, 1. So on our graph, we'll go over 3, we'll go up 1, and we'll put our vertex down right there. Now, in order to make our parabola, we need to look at our a value. Your a value is like your slope. We talked about how the slope of a parabola always has a run of 1, and then your rise is going to equal the number that you have for your a value. So in this case, it's 2. So we're going to do a run of 1 and a rise of 2, and we're going to get to put our dot right here in our parabola. And because parabolas are symmetrical, we're going to put one on the other side as well. And we're just making a sketch. So our parabola isn't going to be perfect. We're just going to look for the general outline of it. So we're going to connect these points together in our curve shape, and we're going to make our parabola. Now, we want to talk about how this parabola is changing from our parent function. Your parent function starts at 0, 0, and it has an a value of 1. So a rise and a run of 1. So what we want to do is talk about how did this parabola move or change. And there are 4 things we address. One of the things we look at is whether it moved right or left from that original parabola. And we can see that this parabola moved 3 places to the right. Okay, so that's one change. The vertex of this parabola moved 3 units to the right, right there. We also can notice that this parabola moved 1 unit up. So the vertex moved 1 unit up. Okay, so that's 2 different transformations. The other 2 transformations we look at have to do with that a value. Okay, the a value tells us whether our parabola opens up or down, okay, based on whether that a value is positive or negative. So our a value is positive, so we're going to say this parabola opens up. Now, that's not actually a change from our parent function, but it is a piece of information we want to talk about. And then the last thing we want to look at is compared to our parent function, was this parabola either stretched or compressed? Is it skinnier or wider than what we started with? And so in our original parabola, my a value was 1. It had a run of 1 and a rise of 1. We can see this one was stretched because now our rise is 2. So it's like we stretched our parabola up taller. And so what we would write is that this parabola was stretched by a factor of 2. And the factor that it gets stretched by just matches your a value. Okay, so stretched by a factor of 2. Now, sometimes you're given an equation to work with. Other times, you might be given the transformation and you have to figure out what's going on based on that. So let's look at what we've got here. We know that this parabola was translated down 1 unit. Well, my k is what controls my up and down movement. So if it went down 1, that means my k value is going to be a -1. We know our parabola was translated left 5 units. So again, our h value controls right and left. If it went left, that means my h value is going to be a -5. Looking at a, it tells us it opens up, so we know it's going to be a positive value, and it's told it's stretched by a factor of 3. So that means my a value is +3. So now it's time to identify my vertex. Remember, my vertex is made up of h, comma, k. My h value, -5, that's the x value in my vertex, and the k value, -1, that's the y value of my vertex. So let's put this parabola, this vertex, on my graph. I'm going to go -5, -1. Oops, right here. All right, now we got to look at our a value in order to sketch this parabola. My a value is a +3. So it's going to open up. It means I have a run of 1 and a rise of 3. And I'm going to put 2 dots there because it's going to be symmetrical. And then I'm just going to sketch this parabola. And hopefully you can see this parabola is really tall and skinny, which is why we would say it's stretched. And then the last thing we need to do is write our equation in vertex form. So when we write our equation, most of this is going to stay the same. All we got to do is plug in our a value, which is 3. And then we're going to do x minus h. Now be careful here. The h value that I have is -5. So I could write x minus -5, but mathematically that's not how we would write it. It's not the sophisticated way to write it. A minus -5 becomes a +5 squared. And then we've got plus our k value, which again, we wouldn't write plus -1. So when you have plus and a negative, that's actually just -1. And that's how you can take the information and create a parabola from it and come up with your vertex form.